we're going to take a look at the alternate interior angle theorem. So the alternate interior angle theorem is one of our theorems that has to do with parallel lines and transversals. And so what it says is that if two lines are parallel, not two lines, are parallel, then the alternate interior angles are congruent. Alternate. So this is one of several different theorems that we have that starts with this: if two lines are parallel apart, then the alternate interior angles. And then we can say something about the angles that are created then. So if I want to prove this, let me start with my diagram first. So I'm going to start off with two lines that are parallel to each other, and then they're cut by a transversal. And I'll label all these. Call this P and Q, and this will be my transversal T. And what I want to show is that a pair of my alternate interior angles then will be congruent to each other. So I have a couple pairs that I can pick from. It doesn't really matter which ones I choose, but I just need to pick a pair of alternate interior angles. So like 3 and 5, for example. I could have also picked 4 and 6. Doesn't really matter. So what my given will be in this case is, okay, so my given is just that the lines are parallel. P is parallel to Q. And what I'm trying to prove is that 3 and 5 are congruent. Angle 3 is congruent to angle 5. So let's stop for a second and just notice how our statements here are given and are proved match up with our theorem that we have. So I'm trying to say that if two lines are parallel, so I'm starting off with two lines are parallel, that is my given, and then I want to say then the alternate interior angles are congruent, and so that's what I have here as my proof. So that's not too bad. We can just jump right in. I have a different shade of red. Oh well. Okay, so statement number 1 will just be my given that P is parallel to Q. So the question is, so before I even actually jump into the proof, I guess I should think about where I'm going with this. So as of right now, the only thing I have to talk about whenever I have lines parallel is my postulate, and that postulate is the corresponding angles postulate. The corresponding angle postulate says that if two lines are parallel, then the corresponding angles are congruent. So that's the only thing I have to work with right now. After I prove this theorem, of course, I can use it, but I only have my postulate available to me. So if I am trying to mark what my goal is, to prove 3 and 5 congruent to each other, well, how can I match these up? Well, let me just start with angle 5, for example. What do I know that angle 5 is congruent to? Well, it's congruent to angle 7 because they're vertical angles, or I need to try to make the jump up to this set of 4 angles up here. And so I also know that it's congruent to angle 1 up here because they're corresponding angles. That's the only thing I can really use to connect these two sets is my corresponding angle postulate, so I can say that these are congruent. And then I can talk about the fact that 1 and 3 are vertical angles, so they'll be congruent. So I can use the transitive property in there, link all this together. But the big point here is that to prove my theorem, I need a postulate to start off with. In this case, that postulate is the corresponding angle postulate. So let me start with that. Let me start with let's see, now I've put a whole bunch of marks here. So angle 1 is congruent to angle 5. How do I know that to be the case? Well, I'm using my only statement that's given to me, and that's P and Q are parallel to each other. So I'll say that if two lines are parallel, then the alternate interior angles are congruent. The alternate, or sorry, not the alternate interior, that's what I'm trying to prove. Then the corresponding angles are congruent. The corresponding angles are congruent. So where did I say the lines are parallel? I said that up in 1. So that'll be what I'm citing here. Then the corresponding angles are congruent. That's what my statement says right now. So I've got 1 and 5 congruent, great. And now I just need to talk about 1 and 3 so I can link this all together. So how do I know that 1 and 3 are congruent to each other? Well, it's because I know that they're vertical angles. And so I need to start with that. This is one of the two things I can assume from diagrams, and that these angles are vertical. So angle 1 and angle 3 are vertical. And this is one of my favorite reasons, assumed from diagram. Okay, so what do I know about vertical angles? I know that they are congruent to each other. Angle 1 is congruent to angle 3. My reason for that is my vertical angle congruence theorem. It says that if two angles are vertical, then they are congruent. They are congruent. Okay, and so I'll just make sure this matches up here. What am I saying right now? That they are congruent, angles 1 and 3. How do I know that? If two angles are vertical, where did I say that? Up here in statement number 3, so I will cite that. And so now I just need to link these together. So I'll end this here with statement number 5, and that is that angle 3 is congruent to angle 5 using one of my other favorite reasons, which is, of course, the transitive property. What the transitive property says, if two things are equal to or congruent to the same thing, then they are congruent to each other. And so in this case, I have that angle 3 is congruent to angle 1, that was in statement 4, and angle 5 is congruent to angle 1, that was in statement 2. Since 5 and 3 are congruent to the same angle, they will be congruent to each other. So I will cite 2 and 4. So that is my proof of the alternate interior angle congruence theorem. Not too bad, only 5 steps. I just want to point out again that the only reason that the alternate interior angles are congruent is because these lines are parallel. If these lines are not parallel, of course, they would not be congruent to each other necessarily. And then what I should have done at the beginning was I should have marked these as being parallel, and I forgot that. Oh well. So there's my proof of the alternate interior angle congruence theorem.